Hello and thanks for tuning in to today's video. My name is Max and today I wanted to introduce a new video series. In this new series I wanted to document my trials, errors, and successes as I attempt to build a thrust vector controlled model rocket, which for now I'll abbreviate as TVC. My hopes with this series is to take you through my attempt to build a thrust vector controlled rocket in great detail, and if I'm successful, maybe to even serve as a guide to anyone else who would like to build something similar. Now, some of you may be asking yourself, what exactly is a thrust vector controlled rocket? And to explain this, I first have to explain a few things about conventional rockets. To put it in the simplest and most concise manner, essentially what a rocket is, it's a fancy tube with an aerodynamic nose cone on one end and a powerful motor on the other that flies through the air at hundreds or even thousands of kilometers an hour. In this configuration, rockets are inherently unstable. What I mean by this is during their flight, due to aerodynamic forces, rockets want to constantly go out of control, which can look like tumbling, spiraling, flipping, etc., etc. To fix this issue, most rockets have fins, which are a form of passive control. Passive control in this case refers to the natural tendency of the rocket and its fins to passively correct any instability that may arise, without requiring any active input. You can imagine it like a wind vane. Due to its fins, a rocket will have a natural tendency to orient itself in the direction of airflow. Now, fins are great and all, and they're very simple and easy to build and work with. However, they have their limitations. For example, they cause a lot of drag, which can reduce the performance of a rocket. Additionally, they only work if there's an atmosphere, meaning they don't work in space. And what about if you actually want to control a rocket's trajectory? This is where thrust vector control comes into play. Essentially, what thrust vector control is, it's a method of controlling a rocket by adjusting the direction of its thrust, which is typically accomplished by moving the rocket's motor/engine. And in fact, this is actually the type of system that is used on full-scale orbital rockets, which is why they typically don't have fins. And this is exactly what I want to try to replicate. Don't be fooled, however. This is a pretty difficult problem. Imagine it like trying to perfectly balance a broomstick on your hand, except this broomstick is a rocket, flying on a powerful rocket motor, through the air at hundreds of kilometers an hour. However, there have been many people before me who have accomplished this, so I know it's not impossible. One of the most famous of which is Joe Barnard, who has not only managed to thrust vector control a model rocket, but has also managed to propulsively land a model rocket like SpaceX. Here's an example of a TVC rocket from BPS Space. So now that we have an understanding of what I'm trying to accomplish, let's move on to the first step. In my next video, which should be uploaded at the same time as this video, I will be going over the design and construction of my TVC rocket's flight computer. For now, thanks for watching. If you enjoyed this type of content, please like and subscribe, and stay tuned for my next upload.